Hello, everybody. So this is day 2 of literal equations. And when we started talking about literal equations on Tuesday, what we looked at was this scenario where Marcus was going to take a vacation to Spain. And in the country of Spain, all of the temperatures are in Celsius. So Marcus was going to take the Celsius formula and rewrite it and solve for F so he could easily convert the Celsius temperatures to Fahrenheit. And so that's what we did yesterday was we took this literal equation and we rewrote it. And after we rewrote it, we used it to actually solve problems. And that is the whole purpose of rewriting a literal equation, is to give you that ability to solve problems and to solve for different variables of the literal equation. And so here's the notes that we did on Tuesday with the definition of a literal equation, which is that equation or formula with two or more variables or symbols, or an equation that is typically letters, numbers, or symbols. And then we also notice that the characteristics, or what we're trying to do with these, is to rewrite the formula or equation in terms of one of the variables, or solve for a particular variable by using inverse operations. And so that's what we're going to do today with some of our examples, and then with your assignment afterwards is we are going to rewrite the formula, and we're also going to solve for variables using inverse operations. All right, so I have some examples here, and please don't let the number of examples scare you. This is just designed to show you different ways of doing these, because these are the types of literal equations that you're going to encounter. So let's look at the first one, which is to solve A, which is area, equals base times height, for H, which is the height. All right, so we start here with the literal equation A equals BH, which is area equals base times height. So the operation that I see here is multiplication. And since I'm solving for H, I want to isolate H to one side of the equation. So what I would do here is, since I'm multiplying by B, I would divide both sides by B. And when I do that, those cancel out. So I am left with A over B equals H. Or we would say the height equals the area divided by the base. Okay, so notice how everything is opposite here. Instead of having multiplication, I now have division. Okay, so that's our first example. So our next example is to solve m equals x plus n for x. All right, so if you notice here, we're going to say solve m equals x plus n for x. And hopefully you're doing these with me, even though I didn't say to. I hope and trust that you are. So if I'm going to solve for x, the same thing is I want to isolate the variable x on one side of the equation by itself using inverse operations. So since I'm adding n, the opposite of adding n would be to subtract n from both sides. So n minus n cancels out and becomes 0. So I'm left with x equals m minus n. All right, so the next one is to solve A equals pi r squared for r. All right, so when you see something like this that involves an exponent, what you need to remember is what is the inverse operation of an exponent. So we're looking at area equals pi r squared, and we're looking to solve this for the r. Okay, so if I start with area equals pi r squared, again, on the right side of my equation, I see multiplication. pi r squared means pi times r squared. And so I want to also at the same time isolate r by itself on one side of the equation. So the opposite of multiplication would be division. So I divide both sides by pi. All right. So again, pi divided by pi cancels out and becomes a 1. So I'm left with area divided by pi equals r squared. But we need to solve for r. So the inverse operation, or the opposite of an exponent, is to take the square root. So I would have the square root of area divided by pi equals the square root of r squared. So when I take the square root of r squared, those canceled out, and I'm left with r by itself. So r is going to equal the square root of the area divided by pi. Okay? And that's just based on the fact that the inverse operation of an exponent is the root operation. All right, so let's look at the next one. This one says y equals 12x plus n, and we're solving for n in this one. All right, so again, I just want to isolate n by itself. So when I look at this particular literal equation, 12x is an expression. And since it's an expression, I'm going to treat it as one singular term. So it's a positive expression. So the opposite of a positive expression would be to subtract that expression from both sides. So when I do that, again, those cancel out. So I'm left with y minus 12x equals n. So I have now solved for n. All right, so then I have P equals IRT, which is the principal equals interest times rate times time, and we're going to solve it for R. All right, so again, I want to isolate R by itself on one side of the equation. So I have principal equals rate, interest times rate times time. So I'm trying to get the rate, or R, by itself. So again, since I have multiplication here, the opposite of multiplication would be to divide both sides by I and T. Okay, so we're just kind of breaking this apart. So when we do that, those all cancel out and become a 1. So the principal divided by interest times time equals the rate, or P divided by I times T equals R. Okay, so again, we just used our inverse operations for that. So now I have x plus y divided by z equals 3. And I want to solve this for y. All right, so what I have here is division. So the opposite of division is multiplication. So somehow I need to move this z to the other side of the equation. So I'm going to do that by multiplying it by the reciprocal, which would be z over 1. And again, what I do to one side of the equation, I must do to the other side. Okay? So when I multiply this side by z, those are going to cancel out and leave me 1. So I'm left with x plus y equals 3 times z over 1 is the same as 3 times z, which is 3z. Now, here I'm trying to solve for y. So since I have a positive x over here, the opposite or the inverse of the positive x would be to subtract x from both sides. So when I do that, those x's cancel out and become a 0. So I'm left with y equals 3z minus x. And again, notice how everything is opposite. Instead of dividing by z, I'm multiplying by z. Instead of having a positive x variable, I now have a negative x variable. So that's one way you can always check yourself with these literal equations, is if the new equation that you've written, making sure that everything in it is opposite or inverse of the previous equation. All right, now the last one is going to be to solve, and that should say a equals 1/2 h times b base 1 plus base 2 for base 1. Okay, I forgot to put the a in there. So what we'll do then is when we write it over here, okay, that's what I should have had in there, is a equals 1/2 the height times base 1 plus base 2. All right, so what I'm doing here is I am solving for base 1, or b1. So let's look at this again. I've got 1/2 times the height, and then I've got base 1 plus base 2 in parentheses. So the best way to think of this is you're doing inverse operations, but you're also kind of doing a reverse PEMDAS. Because if you were doing PEMDAS, you would do parentheses, and then the multiplication and division from left to right. So if we're going to do the opposite or the inverse, we would start from left to right with our division, since that is the opposite of multiplication, and then we will end up doing subtraction at the end. All right, so let's start with the 1/2. So now I need to multiply this entire side of the equation by the reciprocal of 1/2, which is 2. Because that way 1/2 cancels itself out, because 2 times 1/2 is 1. So that's going to leave me with just h times base 1 plus base 2. But what I do to one side of the equation, I must also do to the other side of the equation. All right, so that means 2 times h is going to be, or excuse me, 2 times a is going to be 2a. So now I'm left with 2a equals the height, or h, times b1 plus b2. So I still need to do division because I'm doing multiplication over here. And remember, again, I'm doing kind of a reverse PEMDAS. I'm saving my parentheses for last as opposed to doing the parentheses first. So if I divide the right side by h, I need to divide the left side by h. Those will cancel out. So again, I'm left with 2a divided by h equals base 1 plus base 2. So I'm trying to solve for base 1, or b sub 1. So the opposite of adding base 2 is going to be to subtract base 2. So when I do that, I'm left with 2 times a divided by h minus base 2 equals base 1. So that's how I would solve that kind of a problem. Okay, so these examples are all different types of situations and different types of literal equations you're going to encounter, which is why I tried to throw a variety of examples in there. So I hope it's been beneficial for you. If you look here on your Canvas posting, literal equations day 2, what you see here is you have got 12 problems to do, and they're all very similar to the examples that I showed you. Okay, so just do them on a separate sheet of paper, upload your work to Canvas for me, and please, 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 if you have any questions or need assistance, you can email me, or I will be on Google Meet from 10:45 to 11:45. So have a great day, everybody, and I will have something else for you on Friday.